In this last section of chapter 12 in geometry, section 6, we're going to actually connect the geometry of a circle that we've been talking about to algebra. And specifically, what we're going to do is we're going to identify the center and the radius of a circle from a graph in the coordinate plane. We're going to identify the center and radius of a circle from the equation of a circle in what's called standard form. We're going to graph a circle in the coordinate plane from its equation. And then we're going to write the equation in standard form of a circle when they give us the graph, or write the equation of a circle when they give us some information about the circle. So this is going to be connecting geometry to algebra. So if we have a circle that is centered at the origin, recall that the origin is the center of our coordinate system, 0, 0 is the ordered pair for it, then the equation of that circle in standard form looks like this. So if the center is at the origin, then the left side of the equation is just x squared plus y squared. And on the right side, we have the radius squared. So if you look at a circle in the coordinate plane, such as this one, since the center is at the origin, it means that we have the form x squared plus y squared is equal to r squared. So really all we have to do is determine the radius if the center is at the origin. And if you look at our graph over here, we can count, and the radius there is 3. So we would have to take the 3 squared, and that gives us 9. The equation of this circle then would be x squared plus y squared equals 9. Again, if the center is at the origin, the left side is always just x squared plus y squared. Now, if the center is anywhere other than the origin, then we have a different standard form. So this is the standard form when the center is not at the origin. And this would be when the center is at HK. So what I want you to notice here is, in the parenthesis with the x, we have the opposite of the x coordinate of the center. And similarly, with the y, we have the opposite of the y coordinate of the center. So let's take a look at writing an equation of a circle in standard form when the center is not at the origin. So here's our first example of that type. Here's the center. So our h is 1 and our k is -9. Remember, the center is at HK. When we write the equation, the left side is going to match this form. And the right side is going to be the radius squared. So on the left side, we will have x, and then the opposite of h would be x minus 1 squared. And with the y, we need the y, and then the opposite of the -9 would be positive 9 squared. The only thing that remains is we need the radius squared. The radius was given to be 5, so I need 5 squared, which is 25. And that would go on this side, the right side. So that would be our equation in standard form for the circle with center at 1, -9, and then radius 5. Again, notice the number in with the x is the opposite of the x coordinate of the center, and the number in with the y is the opposite of the y coordinate of the center. Let's try another one of these. Okay, you'll notice the center is not at the origin. So that means we're going to use this form, x minus h squared plus y minus k squared equals r squared. When we go to write our equation, we need to put the opposite of the x coordinate. So the opposite of -2 would be +2. And we need to put the opposite of the y coordinate. So the opposite of 5 would be negative 5. And then we need the radius squared. So the radius was given to be 7. 7 squared would be 49. So on this side we get 49. That would be our equation in standard form. Really not that complicated, and something you'll use again as you continue in algebra. Now, number 4 is a little bit more involved, because in number 4, they did not give us the center and they did not give us the radius. So first, we have to find the center. And to find the center, these are the endpoints of the diameter. So we know on this circle, one endpoint is at negative 2, 1. The other endpoint is at 4, 9. So to find the center, we can use the midpoint formula that we learned earlier in geometry. The midpoint formula was this. You take the x1 plus x2 over 2, and you take the y1 plus y2 over 2. So for our center, we're going to have to take negative 2 plus 4 divided by 2. That'll give us the x. And then 1 plus 9 divided by 2. That will give us the y. So our center, negative 2 plus 4 is 2. 2 divided by 2 is 1. 1 plus 9 is 10. 10 divided by 2 is 5. So we now have the center. The second step is we have to find the radius. Well, to find the radius, we really need the distance from this center point, 1, 5, out to one of the endpoints. So we could use the distance formula. Remember that distance formula from earlier again in geometry looked like this. The square root of x2 minus x1 squared plus y2 minus y1 squared. And we're going to be using the center point and one of the endpoints. So we're going from the center at 1, 5 to one of the endpoints, 4, 9. So my radius would be the square root of, and then I have to take 4 minus 1 squared plus 9 minus 5 squared. Now if I work that out, 4 minus 1 is 3. 3 squared is 9. 9 minus 5 is 4. 4 squared is 16. So my radius comes out to be the square root of 25. And there's actually two answers there, 5 and negative 5. But as we've talked about earlier, we can't always use all of them. So here's my radius. The radius is 5. And now finally comes the time to write the equation. So our standard form is going to be x minus the h squared plus y minus the k squared equals the r squared. We have to use the opposite of the center point. So x minus 1 squared and y minus 5 squared. And then we have to square the radius. So when we square 5, we get 25. So this would be our equation. So as I had told you through geometry, the midpoint formula, the distance formula, they'll be used throughout, all the way through to the end in our final chapter and our final section. Let's take a look at one where they give us the graph of the circle. Well, always when you write the equation, you need the center. If they give you the graph, you can simply pick out the center. Here's the center. The center is at negative 1, 3. And then you need the radius. The radius is going to be the distance from the center, negative 1, 3, to a point that's on the circle. Well, this time they give us the point negative 5, 6. Now, we've already seen that we can use the distance formula to get that. But you can also use the Pythagorean Theorem. If I'm going from negative 1, 3 to negative 5, 6, I go left 1, 2, 3, 4, and then I go up 1, 2, 3. Since I went left 4 and up 3, I can find the distance between these 2 points by saying the radius squared will be equal to 3 squared plus 4 squared. That's just the Pythagorean theorem. So r squared would once again be 25. R, of course, would be 5 and negative 5. And as we've already seen, you can't use the negative for the radius. So here's my radius. Of course, the distance formula would have worked as well. Finally, it's time to go ahead and write the equation. Since the center wasn't at the origin, we use the form x minus h squared plus y minus k squared equals r squared. Once again, don't forget we use the opposite of what's the center. So I'll have x, and then the opposite of negative 1 would be x plus 1. And then we have a y, and the opposite of 3 would be negative 3. And then we have to use the radius squared. 5 squared, once again, 25. We've seen that a couple times. Okay, let's take a look at another one. Now, this one, they give us the center and they give us a point, and then they ask us to write the equation. Let's start out with a graph. So the center is at 1, 4. 1, 4. So there's my center. And then it goes through the point 3, 4. 3, 1, 2, 3, 4. So that's a point that's on the circle. Always to write the equation, you need the center, which they gave us, but then you need the radius. This time I think we can get the radius by just counting. I think this distance is straight to the right 2. So the radius is just 2. And now we can write the equation. Since the center is not at the origin, for our equation, we use the form x minus h squared plus y minus k squared equals r squared. Again, we're using the opposite of the center point, so x minus 1 squared, and then y minus 4 squared. And when we square that radius, 2 squared is 4. Let's go ahead and graph this one as well. Since the radius is 2, we'll go 2 to the right. We already have that point. We'll go 2 up. We'll go 2 to the left, and we'll go 2 down. And then we'll go ahead and sketch that circle. Again, when you sketch them, the circle does not have to be perfect. We just want it to go through those critical points. Let's try another one. Now, in this one, they gave us the equation. So here's the equation. And they asked us to pick out the center and the radius. Now, don't forget for the center, we have to use the opposite of what we see in the equation. So the opposite of minus 4 would be plus 4. The opposite of plus 2 would be minus 2. Let's go ahead and plot that point. So we go over 4 and down 2. There is my center. Now for the radius, we know that this number at the end is the radius squared. So r squared is equal to 36. We'll take the square root of both sides. We get r equals 6, and also r equals negative 6. But as we've talked about, the radius cannot be negative, so the radius here is 6. To sketch our graph, we'll start at the center. We'll move right 6. 1, 2, 3, 4, 5, 6. Up 6. 1, 2, 3, 4, 5, 6. Left 6. 1, 2, 3, 4, 5, 6. And down 6. 1, 2, 3, 4, 5, 6. And then we'll just try to sketch a graph that goes through those points. Again, this circle does not have to be perfect. We just want it to go through these critical points. And, of course, we do want it to look like a circle. Let's try another one. the very same thing is asked of us here. We're to find the center, find the radius, and sketch the graph here. So let's do the center first. Keeping in mind for the center, we have to use the opposite of what we see in the equation. So the center here would be at 4, -3. As for the radius, we have to keep in mind that the radius squared is what we see in the equation, so the radius would come out to be 4. Oh, sorry about that. Oh, sorry about that again. Let's go ahead and sketch the graph. Now, to sketch the graph, we'll plot the center point. So the center point is at 4, -3. 1, 2, 3. That's our center. The radius is 4, so we're going to go 4 to the right. 1, 2, 3, 4. 4 up. 1, 2, 3, 4. 4 left. 1, 2, 3, 4. And 4 down. 1, 2, 3, 4. And then we're just going to try to sketch the graph of a circle going through those critical points. And we want it to look like a circle, but it of course doesn't have to be perfect. Okay. Let's try one where we have to write the equation again. So here they've given us a point right here, and they've given us the center. Since they gave us the center, that's the first thing we need. Let's plot that point. Over 2 and up 6. 1, 2, 3, 4, 5, 6. The point that they gave us is -1, 2. So -1, 2 be left 1 and up 1, 2. Before we can write the equation, we need to find the radius. And to find the radius, we can either use the distance formula, we've done one like that, or use the Pythagorean theorem. Now, I remember that in class, most of you preferred the Pythagorean theorem. So we're going to go ahead and try this one by the Pythagorean theorem. When I go from the center here, I go down 1, 2, 3, 4. So I went down 4, and I went over 3. So to find my radius, r squared will equal 3 squared plus 4 squared. Now we've seen this a bunch of times. We know that this gives us a radius of 5. We're ready to write our equation. Since the center is not at the origin, we have to use the standard form x minus h squared plus y minus k squared equals r squared. We have to remember that we use the opposite, so it would be x minus 2 squared, and it would be y minus 6 squared. And then we have to remember that we use the square of the radius, which we've done several times. It's 25. Let's go ahead and sketch the graph. When we go to sketch the graph, it's pretty easy to go right 5. 1, 2, 3, 4, 5. But to go up 5, we go off the graph. That's okay. Sometimes that happens. And for those going into Algebra 2, it'll happen a lot. So I go up 1, 2, 3, 4, 5. So this would be my point up there. Then I go left 5. 1, 2, 3, 4, 5. And then I go down 5 right here. Now, remember, I'll also go through this point over here. So when I sketch my circle, I have 5 points that I'll go through. And again, we want it to look like a circle, but it in no way has to be perfect. Okay? Let's try one more, and then we'll be done with the new material, and you can move on to your practice. So in this one, we're asked to find the center and the radius, and then sketch the graph. It's in standard form. So for our center, we remember that we have to use the opposite of what we see in the equation. So we'll have a -8, and we'll have a -5. So -8, and then down 1, 2, 3, 4, 5. There is our center point. For the radius, we remember that in the equation, we actually see the radius squared. So 121. When we take this, sorry about that one last time here. Oh, there we are. We take the square root. We find out that the radius works out to be, well, it would be positive or negative 11. But remember, we cannot use negatives for the radius. So here is our center, and they asked us for that. Here's our radius, so we'll also box that. We're going to go right 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're going to go up 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're going to go left 11, and we can see that that will go off the graph, but we know how to deal with that already. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Way over here. And then we're going to go down 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Again, when it goes off the graph, you simply extend your graph to make it fit. So you don't give up and you don't just say it's not possible. And since we have the numbers on the coordinate system, we do not try to renumber our coordinate system. So when I draw my circle, I have these 4 critical points that I want to go through. This is a big circle. That makes it harder to draw. And that would be our answer. Okay, so that's the end of our last lesson. The only thing left is a review of this chapter, which you'll do next week. So I hope this goes well, and it does make the connection from geometry to algebra. Good luck.